Hello and welcome back to the Java programming series. So in this video, we are going to be looking at and understanding control flow and loops. So let's cut right to the chase. What is control flow? So control flow is the first topic we're tackling. So essentially, all of the programs that we've been writing so far in Java, at least, have been very procedural in nature. So for example, if I have like int a is 1, system.out.println, I don't know, a plus 1, and we get 2. Pretty straightforward. And my point of showing you that is that we know that this line executes for sure, and then this line executes for sure. So it's a very we've been programming in a very procedural, definite way. But in order to add versatility to our programs, more versatility to our programs, we need to be able to operate on conditions based on the values of certain things. So let me explain. Control flow is the idea of executing code based on conditions. And these conditions are Boolean. So, of course, uh, uh, code execution based on Boolean conditions. Okay? Essentially, that's all that a control flow is. Yes. So the first thing we need to look at under control flow, so in terms of the actual tools and keywords we use in Java at least, in order to use control flow are if statements. Now these also break down into if, else, else if, and else. So these are a couple of keywords and combinations of keywords we have to look at under the idea of if statements, which is one of the two ideas under control flow, the other one being what we call a switch case. And we will look at that after. So what is an if statement? Well, this is how we structure one to begin with. We have the keyword if, we have parentheses, and then we have the body of the code, of course, as anything else in Java, like classes, methods, whatever. We have the body of it in curly braces. Now, what we actually put in parentheses after the if is the condition that we want to execute the code in the body under. The condition under which we want to execute the code in the body. So if I type in condition and just define condition as a Boolean condition, set that to true, say if condition equals true, then just system.out.println, let's say condition is true. Okay. So if we actually run this, we get out in the console condition is true, and that's because this condition we placed in the parentheses of the if statement was in fact true. Condition is true, and that's equal to true, of course. Now, a couple of things to explain before I go any further with control flow. So this may seem a bit unrelated, but arithmetic. I just wanted to ensure that you know basic Java arithmetic. So of course we use the addition symbol, the plus, for actually adding two operands, A and B, for example. Of course we use the hyphen, dash, whatever you call it, as the minus sign, so that's subtraction. We use forward slash for division. I'm just going to backspace this so it doesn't take that as the end of the comment. And there is also the multiplication, which is just an asterisk. So like A times B. And there's some other tools as well, some built-in stuff as well. But I just want you to know that for sure. Because I might just use it in nature and then perhaps forget to explain what these different operators do. But anyways. And in addition, there are these things called logical and relational operators. So I'm just going to say operators here. under logical, there is and the way we actually write that is the double ampersand. And there's also or, which is like the double vertical line. And there are relational operators, and these break down into like greater than or equal to, less than or equal to, equals. So like just basically testing for equality. To equal sign means we're comparing two values. Like here, condition equals true. We want to check if conditions is true. Whereas one equal sign it indicates assignment. So the logical operators essentially allow us to implement different combinations of criteria together in overall Boolean statements. So, for example, if I had Boolean condition 1, and let's set that to false, we can say in this, just for the sake of using condition 1, and, so condition 1 is true and condition 1 is false, then execute this. Meaning, when we have an and, the two operands it takes on either side of it, of course, the two operands, they both have to be true. Hence the name and, hence the word and. Whereas or, as the name implies, of course, means that at least one of them has to be true. They can both be true, that'll still execute and still have an overall value of true, the Boolean statement, but just at least one of the conditions has to be true. Okay? And one of the Boolean values. So this basically saying this will this line of code will execute only if this is true and this is true. So if we run it, we should see the same output. Yes, the condition is true because this overall condition is true. Now, of course, we can also do or, and it'll run the same way since both of them are true. So it meets the criteria of at least one of them being true. Relational is, of course, these basic math operators like that we use in mathematical inequalities. Now we can move on to another kind of clause, which is called the else if clause. What that is basically we can only add it if there is a preceding if statement pretty much right before this else if. And what it does is checks another condition if the condition of the immediately preceding if statement is false. It's not true. So if this condition in this example, if this condition that I've selected here, that I've highlighted, if that's false, then what actually happens is we're going to check for this condition in these parentheses. So like it can be condition 1 is true, and system.out.println other condition is true. Okay. So so if this value is to false, so the preceding if statement, if its condition of value is to false, then we check for another condition, and if that's true, then execute the body of the else if. So if we run this, we still get the same output as before because, of course, this Boolean condition is still true. But if we change this to true, then we get condition is true. However, if we change, let's say this to false and this to false, then we won't actually see any output. Well, wait, we get condition is true. Perhaps my logic was wrong. Condition is true. Oh, yes, I had or. I thought I still had and. Yeah, so there we go. We don't get any output because this condition is not true. So this condition was checked here, condition 1 equals true, but that's not true either. So in this case, we might want what we call an else clause or an else statement. What that does is basically just executes some code in the body, of course, in the curly braces after the else keyword. It executes that code if any preceding conditions, any preceding if or else if, any combination of if/else if clauses is all false. So basically, in this case, if this is false and this is false, hence neither of them execute, we execute basically some default code that we otherwise want to do. And I'll just say in this case, else has executed. Okay. So in this case, we will get else has executed. Okay. So essentially, that's all there is to if statements under the idea of control flow in Java, at least. Now, there is another thing we must cover now, which is called the switch case kind of paradigm or tool, basically, under control flow. So let's kind of just comment this out. Okay, we don't want that running. So let's say we have some integer a equal to 1. And then we just put that there for now. So what a switch case is basically we have one variable, essentially, or I guess we can even have a constant value, but that's kind of useless. So we typically have one variable. We're testing for multiple possibilities, like multiple possible values of it for. Okay? So we're testing it for multiple values that it can take on. Testing it against many different values. So let me put this into an example. So what we're saying here is that our switch is going to be A. So we're going to test the value of A, essentially. One thing to keep in mind is that every case under the switch must be an integer, essentially, or at least in Java, or some equivalent of an integer. If it's not directly one, at least. So case 1, and in this case, we actually use a colon, not curly braces, which is kind of weird, but it is what it is. So basically what this is saying is that we are going to have a switch A and test it against all the cases in the body of the switch case block. Now we can have another case called case 2. I mean, it's not called case 2. It's like the second case is the case that A equals 2. So we can say equals 1. And here we can say A equals, oh my god, equals 2. Okay. Now, if we run this is actually going to do this. Actually, hold up. 1 second. Okay, yes. So I was just thinking there for a moment, and this is exactly what I wanted to show. Just didn't expect that I would do that. But essentially, why this is happening is like it's saying A equals 1 and A equals 2 is because we didn't put the break statement at the end of each case. We need that in order for only one case to execute at a time. So we only ever want one case to execute, and that is from top to bottom, the order in which it goes in, basically in terms of priority. Now, sometimes you may not want the break statement in order to correspond with the functionality of how you want your program to actually work. But typically, we want the break statement at the end of each case, hence only one case executes. Now, if none of the cases are actually met or satisfied, we can have if we want to do something in that case, we can have what we call a default case. So we just use the keyword default colon, and what that does is, of course, it executes whatever code is under it, if none of the cases are met. So in that case, we can say system.out.println and just say default. Okay. Still get a equals 1 because of course a is still 1. But if we equate a to 3, then we just get default printed out because that's our default behavior of the switch case block. Cool. Essentially, and I'm not trying to get too complex here, but essentially that is all there is to the switch case in Java and the if statements, else if statements, and else statements. So overall control flow in Java. So now let's just comment this section out. We don't want this running. Okay. And now we want to discuss the very important topic of loops. So let me just get a good amount of spacing. So loops, and I keep putting a double asterisk. I cannot type today. But loops. The purpose of loops is to repeat code for a certain number of times. Now, that can be an indefinite number of times or quite a definite known number of times. I might have kind of contradicted myself by saying a certain number of times. But basically, repeat code. That's the goal of loops. That can be for a definite number of times or indefinite number of times. Now, there are 3 different types of loops, at least in Java. So there are for loops, there are while loops, and there are do-while loops. Do-while loops I will explain after I fully explain while loops, but essentially all for loops are there are loops there are types of loops we use, and I'll show you exactly how it's syntactically constructed. But there are loops used when we know the number of iterations of the loop that are required. Whereas for while loops, we use while loops when we do not know the number of iterations of the loop. So we basically keep going as long as some condition is held. And you'll see what I mean. But loops are Boolean conditions are integral to loops as well. They're, of course, integral to control flow as well, but they're also involved in basically all of these types of loops, at least to some extent. So just something to keep in mind is that Boolean conditions are always involved to some extent, at least. So for for loops, I'll show you. I'll now show how exactly we should code one. So we use the keyword for. We have a set of parentheses, and we have a set of curly braces in order to specify what code to repeat. That's what we call the body of the for loop, of course. What we actually put in the parentheses defines how many times our for loop runs on the core level. So what we actually put in the parentheses consists of a couple of parts, 3 parts to be exact. So like every time we code a for loop, we have the for, we have the parentheses, and then we have the curly braces with the body inside, all the statements to execute and whatnot. Now, what we actually put in parentheses are 3 things. We have the iterator, and I'll explain what that is. We have semicolon, and then we have the condition, and that is a Boolean condition I was referring to by this. And then we have basically the step. And I don't want to say increment, or I guess we can say iteration or step. Both both names are suitable. But I'll explain what I mean through this example. So the iterator is essentially always an integer, and it's often called I, which it just stands for iterator. So we start with some iterator, some variable, and what an iterator is, it's just a variable that in some way we can always basically, well, at least for the general case, It helps to track how many times the for loop has run, at least to some extent. Okay, I'll leave it at that. I don't want to overcomplicate things or take certain edge cases or anything or counter examples. But essentially, we have some variable to control how many times our for loop runs. That's what the iterator is. Okay. Then we have a condition that the iterator is well, it pretty much has to be involved in for the for loop to actually make sense. So in this case, we want to keep running as long as I is less than 0. And after each iteration of the for loop, so after each time it executes, we want to increment I. By the way, plus plus is the same thing as saying plus equals 1. So just adding 1 to I. And minus minus is likewise minus equals 1. Same thing. Basically, what this is saying is that we start at 0. So I is 0. We want to keep going up until 10, but not including 10, of course. We don't want to execute or run the for loop when I equals 10. And then after each iteration of the loop, we want to increment I by 1. Okay? So if I want to print, let's say 8. I don't even know. It's just a random number. 8 for every time we iterate through the for loop. Or rather, let's print I. That's more useful to us right now. Okay. See, we get 0 to 9 in the console here. And of course, that's because we started at I equals 0. We printed out I, increment I. So increment I by 1. Then it turns into 1. Print that out. And we just keep going all the way up until 9. Cool. Essentially, again, I'm just explaining enough for you to be comfortable with using these types of loops. I'm not explaining every edge case or every possible case or anything like that, but just enough for you to understand these loops, how to use them, and whatnot. So typically, that's what a for loop looks like. Now, of course, you can also, from inside the for loop, alter I. Like, we can also multiply it by 2. So times equals 2 just means, like, multiply I by 2 each time as well. And you'll see that runs fewer times. So, like, it goes 0, 2, 16, 14, and then just terminates. So it executes fewer times because, of course, it reached minimum of 10 much faster. But of course, one thing to keep in mind is since I is in the parentheses here, it's like the iterator. It is only known, it's what we call local to the scope of this. Its scope is the body of this for loop. Scope refers to the space in which a variable can actually be recognized and used. So I here, for example, if I try to print out I here, I'm actually going to get an error. So let's try that. See, we get an error here. Unresolved compilation problem, I cannot be resolved to a variable. This is because, of course, what happens is that since I is defined for inside the for loop, hence its scope, where it's actually defined and known, is only inside the for loop. Once we exit the for loop, Java has this thing called garbage collection. Now, I don't want to go too in detail because that's not the topic of this video, but essentially, so Java's what we call garbage collection removes I from the memory of the for the program, and so of course after we execute and exit the for loop here in this case, I is not recognized when we it's not resolved in technical terms when we actually reference it here. So essentially, that's all there is to for loops. Now, while loops. Now, I'm just going to comment this out. Okay, so now while loops are slightly simpler, actually. So, of course, they follow the same kind of general form as a for loop. We have, instead of for, we have while. We have the parentheses and curly brackets, curly braces specifying the body of the while loop, what actually needs to be repeated. Now, what while loops do are they essentially all we need is a condition, a Boolean statement, a Boolean condition. Okay, some Boolean value. Some Boolean statement that can, of course, be equated to a Boolean value. So, like 1 is greater than 2. If we said while 1 is greater than 2, then whatever's inside the while loop would actually execute infinitely. And that's because 1 is always, I meant less than 2. If I said greater than, I don't remember. Of course, my short-term memory is very bad. But if we said like 1 is less than 2 as the condition here, that means we run the while loop, whatever's inside of it, as long as this condition is true. So as long as 1 is less than 2. Now, of course, that's always true. It's never going to change. So this while loop would execute infinitely. And that's actually a problem that can cause some crashes and stuff on your computer. We don't want a never-ending while loop. We pretty much never want that in any case at all. We want a program to end at some point. But anyways, we have some Boolean condition here. So we're going to define some... Actually, to put this, to kind of combine this with what we have, what we learned in a previous video, we're actually going to import the scanner class. And you'll see where I'm going with this, but essentially, we want to keep taking in user input. I'm just going to create a scanner here, so just bear with me. So let's say string or like input is scanner1.nextLine. So basically, we're taking in user input. Like they just type in whatever they want and then hit enter. We take that in and store that, or like take that in from the input stream, store that into the variable input. Now, while input is not equal to end, we want to keep allowing. Essentially, what we're trying to do here is we want to keep allowing the user to input something until they put in the exact word with this exact capitalization, the word end. So then we want to keep allowing them to input some line of input, of course, characters. Now this is actually going to give an error. Okay. So, of course, it hasn't crashed yet. However, after I put something in... Wait, hold 1 second. Okay, it wasn't the error I was suspecting, but ultimately, what's actually going on here is, you see, even after I put an end, the while loop hasn't terminated. I can still put in stuff, right? And that is because I used not equals to as a relational operator. One thing to remember is that strings are reference variables. They're reference types. Okay? They're of reference type. So we can't compare what we call objects, so reference type variables, using relational operators, really. We have to use all objects essentially should have methods to compare them with other kinds of the same type. Usually that's the case. With strings, we have a dot equals method. So what that allows for is basically comparing a string, so in this case input, to another string, in this case end. So now this will actually... And now, of course, dot equals returns true if the strings are equal and false if they're not. So if I put in 1, 2... What is going on here? Oh, wait, sorry. I meant not... Oh my god, my logic is very off. Okay. While it's not equal to end, we want to keep allowing the user to input something. So 2, 3, 4, whatever, just random gibberish. And then I can type an end, and then I can't type in anything after that. That's because input was redefined to end, and therefore the condition that input is not equal to end, which is what this is saying, is false. So the while loop ended. Essentially, that's all there is to while loops. We have while and then some condition that we want to keep executing the code as long as it's true. So to rephrase that, sorry, we have while, and then we have some code inside the body of the loop that we want to keep executing as long as some condition is true. So now let's look at do while loops. So do while loops, they're exactly like while loops, however, they execute once, at the very least once, no matter what. It doesn't even matter if the condition that's checked for, because do while loops also have conditions like while loops. It doesn't even matter if that equates to false immediately. We still execute the body of the loop at least once, no matter what. So how we actually form one is we have do, and then we have curly braces to specify the body. Then we have while, and then we actually have a semicolon after, and then put the condition in these parentheses. So we can say like while true. This would actually execute infinitely because, well, true is always true. But let's say, I don't know, let's say, I'm going to go back to using condition. So Boolean condition is actually, let's say false. Okay, so, and we're going to say condition here. By the way, when we have some variable that's a direct Boolean value, we don't actually have to say equals false or equals true. If we're checking for it being true, we can just put it itself. So while condition means like while condition is true, because technically this is a statement that results in a Boolean value. So as long as we have a statement that results in a Boolean value, we have a valid condition here. Now to check if it's false, we can just say like while not condition. Now this would be an infinite loop because conditions always false. Well, condition's false, and not condition is true. So not false is true. Not basically just makes true false and false into true. Hopefully you didn't get thrown off by that. But we're going to make it condition just to see what the do while actually does. And we just want to keep printing hello. Just a simple line of code. Let's see what happens. We simply get one line stating hello. And why is that? Why didn't it execute more? And now why did it execute once in the first place if this is false? Because condition itself is false. So this would of course so the condition would evaluate to false immediately and hence terminate the loop. However, as I explained, the do while loop always executes at least once no matter what. Okay? And so we printed out system so we did system.out.println hello, and then the computer checks for the condition. If that's true, then we just like execute the body again, check, and keep repeating that. But if it's false, then the loop terminates. Okay. Now, one thing to note about also regarding variable scope in the same sense, as I explained for loop, the scope in the for loop of the iterator. The iterator's scope in a for loop, sorry, I'm very jumbling up my words quite a lot today. But if we have some variable that's defined inside the body of the loop here, like int I is 0, we can't actually reference I in the condition, nor, of course, outside the loop. Because, well, this body, curly braces, essentially how you should think about scope in Java at least, and given our knowledge right now, of course, there will be some caveats later on. But int I being defined in this set of curly braces means that it's only recognizable, it's only resolvable within that same set of curly braces or some subset of curly braces inside that. Okay? It's not recognizable anywhere outside, not even here. Okay? So if I were to use I here, and like I is less than or equal to 0, we immediately get an underline saying I cannot be resolved to a variable because, of course, we defined it in here. Okay? So that's just something to keep in mind so you don't misuse do-while loops. Anyways, essentially, that is it. That is all there is to the main concepts regarding control flow and um, loops in Java. So we've covered control flow in the sense of if statements, else if statements, else statements, switch case blocks, and we've covered the loops in all three types. So for loops, while loops, and do while loops. So hopefully this was helpful. Hopefully I didn't confuse you. Sorry if I did, but I gave my best shot at explaining as best as I could. Anyways, until next time, see ya.